Hey, just wanted to go over what I figured out why I was getting things so wrong yesterday. Um, I narrowed this down, or what I'm trying to say, I've just removed all the fluff and get right down to the basics here. Basically, this is like a ticker tape that I created here. I made up the story of a cheetah chasing a gazelle and starting from zero, starting from rest, and accelerating over 5 seconds, and in that time covering 30 meters. Now, my goal was for this to be a 2 meter per second squared acceleration, and that's what it is. What I ran into a problem with yesterday was I mixed up what the difference between average velocity and instantaneous velocity was. So what I did, I graphed distance versus time on this, and then I graphed velocity versus time. So I'm going to show you what I did yesterday. So basically, at 1 second, I was going 2 meters per second. At 2 seconds, I was going 4 meters per second. At 3, I was going 6. 4 is going 8, and 5 I was going 10. I don't know if I drew that very well, but then I basically then drew a straight line, and it should have looked something akin to that. All right, and so I wanted to show that the area underneath the line on the velocity versus time graph was was distance, right? So I created the triangle, and of course I didn't draw it too well here, but it's the area there is 1/2 the base times the height, which is 1/2 of, should be 5 because it's 5 seconds, times 10 meters per second velocity, right? And that gives me 25. Well, my quandary was when 30. So what happened to that other 5? Where'd they go? And it bothered me all day yesterday, and it bothered me last night, and I was up at 2 in the morning thinking through this, and finally figured it out. And so here's the problem. The intervals here, 1 second, are 20% of the entire time. We only took 5 seconds, and we took every 1 second we took a measurement. So the time frames are enormous. So the way I should have actually written this, and let me get a good color here. The way I should have actually written this was this is an average. Really? This is actually an average because of how big of an interval it is. So I should have done this more like a bar chart. For the first second, averaged 2 meters per second. For the second, averaged 4 meters per second. For the sixth, averaged 6, and then 8, and then 10. Now then, if you take if you add up the area underneath each of these, you're going to end up with, this is 2 meters per second. I'm sorry, 2 meters per second, whatever. Yeah, the area. Okay, the area is 2. Under here, the area is 4. It's 4 times 1. Under here, it's 6. Underneath that one, it's 8, and underneath that one, it's 10. And when you add those up, it's 30. And that is the right answer. So what is the problem is when I did my points, took them right through. Yeah, didn't draw this very well, but you can see that basically I cut off a triangle on each one of these, right? So that that triangle actually is equal to 1 meter per second squared, whatever. It's equal to 1. 1, 1, 1, 1. You add those together equals 5. So if I had added that area under there, it would have been 5. So that tells me that my intervals were too big to treat average velocities as if they were instantaneous, right? I'm taking a 20% of the entire time and I'm reducing it to a little tiny microsecond dot. All right, so so that's where I ran into my problem, and this is why the SUVAT kinematic stuff was not working out for us, because we were either treating it like this or we were treating it like this, and the two don't match. So that was the problem. There's 3 things that I can see to deal with this. Either take the entire thing and find the average velocity for the entire trip, 30 divided by 5, which is 6, and so use that as the average velocity and just make it constant, and that way we have 5 times 6 equals 30, of course. And so that is the VF plus, no, it is not. It is, I'm not going to go into that. Okay. So the other way to deal with this is to break this up into little itty bitty tiny intervals, which is leading us to calculus, which I very much understand. What the heck happened there? Very much understand, but conceptually, but don't really know how to apply. And IB doesn't do calculus, so. And the other option is to graph it like a bar graph, since we're looking for the area. Now, I think this graph is okay if we're looking for the general trend, and we see that it is a constant acceleration because that's a straight line. It may not be as obvious if we use a bar chart. It'll look like it's a straight line, but unless we go through each of those points with a straight line, we won't be able to tell. But that was my problem. I was treating average and an average velocity as if it were an instantaneous velocity, and I was missing a whole bunch of area under the curve. Anyway, that's it. So I feel better now. I'll probably be able to sleep tonight. Such a nerd. And this is what's kind of sad is this is something I knew intuitively. I've seen it before. I understood it before, but for some reason it just didn't sink in until I did this problem. And so it's like, okay, duh, that makes sense because it's that's the way physics works. You have to graph things correctly and whatever, and know the difference between instantaneous velocity and average velocity. Something you probably would look at this and go, no kidding, Carrie, got it. But there's my major thing. I just wanted to explain it to you so that you would see that I finally got it all figured out. Okay, that's it. Thanks for watching. We'll talk to you later.